Okay, good day class. I'm here to report about our lecture for today is the classification of structures in our structural theory CE 311. Okay. Mm, So for the first part, I will show you different structural elements. No, for this we have tension, compression members, beams or bending members, and etc. No. So for this, the first part, structural elements, we will start with tension members. So you can see, no, tension members. These members are subjected to pure tension, meaning no other forces are includes in these tension members. No, it's only tension. No, example of this are, for example, is this the cables of the Cebu Cordova Bridge. No, as you can see here, no, this is the Cebu Cordova Bridge, and this cable supports the entire what do you call this bridge, no, and these cables are in turn supported by these towers, no, or these piers, no. Uh, so as you can see, tension for cables, so that are the tension members, and this tower is the compression one. As you can see, this is the more detailed part, no. uh, yung cable dito, no, was embedded directly to the ano bridge, no, the to the concrete bridge by bearing plate and this anchorage, no. So marami siyang cables na embedded. So itong load ng bridge na ito, itong concrete bridge, no, is supported by these cables, no, which in turn are subjected to pure tensions. Another example of tension members are the bracing or struts, no. As you can see, these are the structural tie rod, no. These are systems help or that help frames. They act as bracings, no, because without brace, uh, there is uh, instability issues with frames, especially if the beams are long or the columns are no high. So these are some tension members, no. Examples are the structural tie rod systems. They are subjected to pure tensions, no. Okay. So for our next structural elements, we have the compression members, no. These type of members are mainly compressive in nature, no. But sometimes in designing process, with the consideration of some combination of loads, it must be designed based on them, no. And these members, no, we have the phenomenon called the buckling, no. They are susceptible to buckling, and in designing they must also be considered. So for this part, as you can see, we have the moment connection for steel, no. Although our subject is structural theory, I will just introduce some very basic, no, examples of connections in steel, no. For this, as you can see, if the beam is connected on its uh, flange side and with its web side, no, if they are connected in both flange and in both in web, they are considered to be a moment connection or a rigid connection. So this in turn, no, this connection transfers also bending forces or moments to this column. That's why this column is no longer considered as pure compressive, no. It is, although its nature is a compressive one, this column, but because of this connection in its flanges, uh, they are now transmitting moment. So as you can see, this is called moment connection, a combined loading of both bending and compression, or rigid connection. So uh, there's also a column that is only subjected to compressive, no. This is the next example, no. These are called the shear connection. It is also called a simple connection, no. As you can see, only the flange only the web is attached to the column. So in return, because of this attachment only, without the attachment in the flanges, this column only carries shear or axial load. No, although this is not not purely compressive in nature too, but as you can see, the purpose of this connection is just to transfer shear only to the column. Therefore, there is no transfer moment. Therefore, uh, any bending or any moment that is carried by this compression member, this column, is negligible. Although there is a small moment here because of its eccentricity, but we can assure you that some of these, some lang, no, compression members with this type of connection is purely compressive in nature. So you can design this one, this column, pwede nyo palakihin, maghanap kayo since mostly ang kanyang karga-karga is not only is only shear, no moment, no. So this is a simple connection, no. Uh, so ito yung difference silang dalawa, no. Meron tayong attachment sa flanges, then sa web. So this is a moment connection. So ang pinaka basic purpose nito is for the lateral loads, no, or earthquake or wind loads, no. And this one, if you want only the shear, if you want only to transfer shear to the column, but uh, as rule of the thumb, if you want to transfer only shear here, obviously mas malaki talaga yung members natin dito for our compression member or for our column. So these are examples of of compression members, no. So as you can see, compression members mostly are columns, no. But anyway, we have also the arches, no. But as you can see here, the picture pa dito, no. Since these members are susceptible to buckling, this is what buckling looks like, no. Buckled steel columns, buckled RCC columns, no. It's because of the critical load, no. We can compute it using the Euler's critical load, no. So as you can see here, no. In designing of these members, of these compression members, this column, no, compression members in this column, we must also consider the designing of its critical load P to ensure that buckling will never occur. Now, this critical load P will serve as our required loads so that we can have the design strength, no? We can have the adequate design strength for columns. So this one, no, para ma-counteract niya yung forces ng critical loads. So moving on, no, we have the bending members, no. So you can see here, no, they develop bending stress, no. So dito sa example natin sa beam, as you can see, may internal forces tayo. This one is a compressive forces, no, kung ganito yung bending niya, no, itong color dark blue. And we have the tension, no. So compression, tension. So yun naman yung naturo sa atin doon sa strength of materials kung paano ito, di ba? If you can remember, these are an example of a bending member. Example is a beam and also slab. Slab is a bending member, no. You can see in this GIF, no, format, no. This GIF format, you can see. This is a one-way slab because only the displacement or the deflection of this is only one way, no. So that you design it, no, based on a one-way slab design. So slabs and beams are example of bending members, no. So they develop bending stresses. Okay, but some structures, no, slabs, masyado nang negligible ang shear sa kanya, but mostly, no, mostly bending beams, no, beams can develop shear stresses, no. That's why in reinforced concrete design we have stirrups to counteract the effects of shear stresses, no. Shear is beams are very susceptible to shear. That's why we need to design these beams for shear, no, for shear. So we can also say, now, although shear is just a minor part of a beam, we can also say beam is also a shear member. Now, but mostly since it carries bending stresses, that's why when designing any reinforced concrete design, we mostly design for its longitudinal reinforcements because those reinforcements will counteract the effects of the bending. Now, mainly in reinforced concrete, no, the reinforcing steel is placed at the bottom to counteract the tension. No, if this is the if this is our beam, no, if the load is here. But anyways, let's move on. No. So our next member, no, is our next structural element is the shear. No, as you can see, one of the basic and the most example of shear walls of the of shear members are shear walls. No, these shear walls, no, ito yung magka-counteract sa lateral forces, no, especially the earthquake, no. Although itong mga shear walls are typically expensive, but if you design it well, it will greatly help, no, the stiffness of the structure, thus making it safe and in terms of earthquake, no. So you can see some elevator shafts can be used as a shear wall structures, no, double purpose siya, no. It can be a shaft for an elevator, and it can also be a lateral force resisting structure or member, no. That is why in most stories, no, is in matataas na story, uh, yung kanilang mga shear wall, no, or elevator shafts are designed almost in the center of the building, no, kasi I will have an example later. Let's see kung ano yung counteract ng ng earthquake load, no, if meron tayong shear, may elevator shaft tayo sa gitna ng building at saka wala, no. So let's see the examples here, no. So as you can see the examples here, no, in this first window, as you can see, no, in this is the plan, no, nakita nyo man itong movement niya. We have a shear wall or the what you call this elevator shaft, no. Sa elevator shaft nilagay natin sa gitna ng building, no. 1 2 3 4 5 6, no, 6-story buildings. The sixth floor is the roof deck, no, example lang. Nilagay natin itong elevator shaft sa gitna ng structure na yun sa gitna ng building. As you can see, this is the movement, no, for my displacement or the my loading is for the response spectrum, no. This is not the loading for static procedure, but this is the loading for the response spectrum, no. Napansin nyo dito, this is the movement, wala masyadong di masyadong sumasayaw masyado ang building, di masyado yung kanyang yung displacement niya dito. As you can see, compared to this one is much higher, no. And as you can see the columns here, no, mapansin nyo naman na hindi masyado what you call that, hindi masyado stress, unlike dito, no. Dito naman sa second window, as you can see, tinanggal ko yung design na meron tayong elevator shaft, no, at akas shear wall. Na napansin nyo dito, no, is grabe yung swaying niya, no, yung movement ng plan, no, floor plan, no, compared to this, and grabe yung niya dito sa floor 1, no. Dito sa floor 1, grabe yung movement ng kanyang columns, no. And kung tutuusin, pwede natin lagyan dito yung isang elevator shaft, tapos isang elevator shaft naman dito, but ito lang yung pinakita ko na design, no. If you put another shear wall here, tapos shear wall here, tapos tanggalin itong sa gitna, iiba talaga ang movement ito, halos hindi na to gagalaw. So as you can see, no, nakita niyo yung difference between the shear wall, no, as the shear member of a structure, no. Shear walls are mostly the most example, no. Siya ang pinakagrabing ginabigay as example as a shear member. Although yung sabi ko nga kanina, yung beams, sorry. Sa bending, no, although bending member siya, meron pa rin siyang kakaunting shearing sa kanya. So you decide i-design mo siya. This is the purpose of the shear wall. It acts as the lateral force resisting system. So let's move on, no. I am finished with structural elements. No. Uh, so we can move on to what this we call types of structures now. So our very first example of types of structures are frames, no. Yung kanina, mga structural elements na yun o yung mga members, no. Mga members ng example ng frame, members ng bridge or ganyan. So iba yung structure sa structural element. So ito na example na natin dito are the frames, no. So F-frames, ginagamit talaga to siya mostly in buildings, no. So pinaka basic ng frames is composed ng beam and columns, and this is the difference between the no yung gagawin natin ngayon sa theory of structures, because since ng topic natin is ang course natin or subject natin is structures, so uh, we are gonna study about the structures. So ang pinaka nakikita talaga natin ngayon na pag-istudyan natin ng structures are frames, no. As you can see in this left side picture, typical frame, no, steel frame, no. So this is a steel composed of beams, girders. So this is a girder supporting the beam, which in turn these girders are supported by the columns, and these columns are in turn supported by the foundation. And on this on this right part, pansin nyo dito, this is a portal arc, no. This is column and rafters. So rafters, also called, it can also be called the beam, supports the purlins, which in turn the purlins supports the roof. Okay, no? So yung roof, yung bigat ng roof, ita-transfer niya sa purlins. Then yung purlins, yung bigat ng purlins, which is ginagamit siya as support ng roof, ita-transfer niya sa rafters, which in turn these rafters, the weight of these rafters or the load of these rafter, no, are transferred to the column. So, also the wall girts, which supports the walls, no, is supported by columns, no. And finally, this column is attached to the pedestal, no, concrete pedestal, which is the concrete pedestal is supported by the foundation. So this is our typical frames, no. So this is a typical frame, no, portal frame. This is we can call this also as a gable frame, no. This is the connection. So this is steel, this is frame lang, no, common frame. So our next type of structures is truss. Okay. So on truss, no, as you can see in this definition, no, pag yung structure ng truss, no, is required for it to belong, no, at saka wala nang consideration sa depth niya, no, hindi na consideration ng depth niya, unlike sa beams ng ng mga frames, no. The depth is considered, no, especially when architects are involved, no, in designing buildings, no. Ginalimit talaga nila yung depth ng beam, kasi kung hindi nila ililimit yung depth ng beam sa mga bahay, sa mga buildings, matatamaan na yung ceiling. But in case of truss, no, tapos gusto mo ng mahaba siya, tapos hindi naman problema yung depth niya o yung height niya, no, we can use it, no, as structure. As you can see in this right side picture, no, ang haba ng span niya, no. This is typical for covered court, gyms, no, mga gym, mga warehouses na malalaking span, no, na hindi natin kailangan ng column sa gitna, kasi kung may column sa gitna, ang mangyayari dyan is that the column is magiging sagabal sa warehouse o doon sa loob ng gym, no. So we need a structure na mahaba, and not considering its design, no, we can use truss, no. And truss is consists, no, ng slender elements, no, usually arranged in triangular elements. So later, no, lectures, later lessons, no, maintindihan natin bakit naka-triangular sila na, no. It's about stability, but our topic is only the introduction of different structures, no, for this, for our theory of structures, no. You can see we have, and pinakasikat na bridge dito sa ating Pilipinas, the San Juanico Bridge, established noong panahon ni Marcos, no? This San Juanico Bridge is uh, created with different types of truss. So this part ng San Juanico Bridge, since na masyadong mahaba siya, and unlike this one dito na part, pwede mo siyang no, na design na yan, no, mga pre-stressed beams naman yan. Kailangan ng suporta ng truss. So this is the main span ng San Juanico Bridge. Wala pa ako nakapunta ng San Juanico Bridge, but we have different parts ng San Juanico Bridge kasi napakahaba niya. We have the main span and others, no. So as you can see in the main span, makikita nyo walang consideration sa kanyang depth. Bahala na, since na itong truss na ito is kailangan para sa long span. So it was used in San Juanico Bridge, no, sa another sikat na monument, no, ng ating kasaysayan, no. So the longest bridge in the Philippines. Okay, so next we move on to another type of structures, the cables and arches. As you can see, may explanation tayo konti dito. So yung kanina doon sa tension members natin, nag-example ako doon na yung Cebu Cordova Bridge, no. So you can see sa the Cebu Cordova Bridge, may mga cables rin siya. But in a structure, we can see a structure that is composed of both cables and arches. Now, example of this is the tied arc bridge, no. This is a typical tied arc bridge, no. Meron siyang cable at saka arc para suportahan ang load niya. So, explain ko dito kung paano to siya nangyayari, no. We have a load, no. Siyempre itong load na ito, dito yan siya sa bridge, o dito yan siya sa girder ng bridge, susuportahan. So, sino ang susuporta sa bridge or doon sa deck, no? Yung sa bridge deck, kasi diyan naman dadaan lahat ng ng load, no, ng moving loads, no. So ang susuporta sa bridge deck is ang cables, no. Sila ang kakarga, no, parang sila ang hihila ng mga tension forces na ipoproduce nitong gravity load, no. Pag ganyan ang load, so ang mapoproduce na forces are this, no. This causes tension dito sa cables natin. So, nakita niyo itong pula, that are tension forces. So, saan ba ito transfer nitong cables natin, ang forces na ito? So, kailangan rin sila, suportahan rin sila. So, itong cables na to is sinusuportahan ng arch. So, this is arch. So, typically, ang arc is ganito ang shape ng arc, no? So, yung load natin, ito transfer natin sa cables, which in turn, itong cables, ito transfer nila ito sa arches for their support. And in turn, lastly, no, kita nyo itong green, no, since these are the loads, yung arches na ito are the compression, ito siya, no, papasok compression, no. They will transfer it to the pier supports and tying cord. So, bakit siya tinawag tied arc bridge? Kasi tinali siya, no, from the word tie, tinali. So, meron tayong tying cord na which is a beam or the girder, no. So, if this arc transfers it to the pier supports only, hindi siya masyadong matibay, no. Pero although may mga arc bridge tayo na walang tie, no, pero mostly lahat ng mga arches natin are tieds, no. So you can see dalawa ang support nitong arches, no, papunta dito sa pier or supports, no. Then after dito sa pier and supports, no, act sila ng simultaneously sabay, no. Itatali naman ng tied, no. So ganito na. So this kita nyo kung ano ingenuity ng mga engineers, no. Matatalino talaga mga engineers kasi as you can see, no, combinations ng mga different structures, cables and arches. A typical tied arc bridge, no. So if you will design in the future, no, design kayo, maging civil engineer kayo, you can use this type of type of bridge, no. Both cables and both arches, no. Huwag nyo kalimutan tong tying cord or yung beam, no. So you can read this one, no. So we can go to another types of structures. We have the surface structures, no. Itong surface structures, this is just na hindi natin pag-aaralan yan dito, no, kasi iba ang style nito ng pag-solve nito kasi 3D to siya. Ginagamitan to siya ng computer na, no. Ito na lang yung masasabi ko sa type of structures, no, for brief lang na discussion, no. So yung made siya na material ng having small thickness, no, compared sa kanyang other dimensions. So meron tayong dalawang example dito. If flexible siya na surface structure, no? Flexible siya. Ang tawag natin sa structure na yun is a membrane structure. Like example, this one, like mga tents, no? Alam ko na nakita kayo ng tents, no? Mga inflated na structures, no? Pati balloon, no? Ah, so this one is an example of a membrane structure. Mostly it's a flexible and mostly tension ang kanyang tension ang nagsusupport sa kanya, kaya nakita niyo ang daming cables, no? So tension masyado ito, no? On the other hand, we have also the rigid surface structures, no? We call it tin plates or shells, no? And if you are, no, kung meron kayong sa sunod, ma-encounter nyo to kasi ma-encounter nyo to siya sa mga software design, no? Designing software or computer aided designs na mga softwares. Meron kayong pagpipilian doon kung membrane ba siya, tin plate ba siya, or shell siya. So lagi yung tandaan, if you want a rigid structure, di-design nyo ang rigid structure, design nyo, piliin nyo tin plates or shells, no? If not, piliin nyo membrane structures, no? So anyway, I think this is the last, no? Thank you very much, no? You can proceed to another lecture of mine, no? So thank you very much and good day again.